the Always Believe House, and today we're going to be doing a test review over functions. And it is going to be F-U-N, fun. So let's get rocking and rolling. Oh, I need to record this, or there will be nothing on here. So record this, and we are recording a magical whiteboard appears, and let's get rocking and rolling. So on number 1, you have your test review and interview. Which set of ordered pairs represents y as a function of x? Remember, x cannot repeat, correct? X cannot repeat. So which one of these underline the x's? And right here we have 2 zeros, don't we? Okay. Sorry about that. Okay, so the x is repeating in there. So this is not a function. On the next one, we have a whole bunch of 5s, don't we? All of those repeat. This is not a function. Okay, on the next one, we have 2, 3, 4, 5. Check. None of them repeat. So write down x does not repeat. And then on the last one, -1, -2. -1 repeats, doesn't it? Not a function. So the one that is a function is C. C is a function because the x does not repeat. Let's go to number 2. So remember, this is junior high. If the x's repeat, it's not a function. Let's go on to number 2. Now then, on this one right here, our x's do not skip, right? We keep adding 1. So I'm going to do this with gx plus s. We're going to get the growing number and the starting number because the y's are not skipping. You could plug the values in and do it that way. Let's go over here. So what are we doing to go to the right? If you look, you're going from 8 to 1 to -6 to -13. To go down, you keep subtracting 7, don't you? That -7 is your growing number or your constant rate of change. Your starting number has the 0 term, doesn't it? Okay, so this is going to have a growing number of -7 and a starting number of 8. It's going to be -7x plus 8, which matches up to B. So if I were to put 0, 1, 2, 3 in here, I would get these answers. That's another way you could do it, is trial and error. But the answer to number 2 would be -7x plus 8. You could get that with growing number, starting number. Go to number 3. Number 3, we got to figure out if it's a domain and then write down either the domain or the range. This one only has 1 arrow, right? Check, 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 check. This is a function. Okay. And then write down the domain. The domain, put D would equal to 1, 2, 3, and 4. And remember, this would be a discrete function, wouldn't it? Let's go to the next one. I'm going to zoom in some. I hope that doesn't mess up. Let's look at this. Do any of them have 2 bars going away from one number? They don't. Every domain's only used once. The range is your y's. So my range is going to be from smallest to biggest, 2, 4, 6, 8, and 10. You only write down each range once. So that's how you do those. So the domain is on the left of a mapping, the range is on the right. Okay? Don't forget that, it's alphabetical order. Okay. Now then, let's go to number 4. This is going to be a gx plus s, okay? His profit is a function of, underline function of. This is important right here. Write down y is a function of x. And remember, your y is your range. Your x is your domain. This would be your dependent variable. Please write this down. This would be your independent variable. Okay, so you have y as a function of x. Your y is your range, your x is your domain, and it's the dependent variable and the independent variable. Those are the words that would go on your x and y axis. So on this one right here, the profit is a function of the hot dogs. This right here would be your dependent variable, and this would be your independent variable. Okay, now then, is the discrete or continuous? If we make a t-chart, sorry about that, hopefully that doesn't mess up. Let me talk about this. The hot dog vendor rents the stand for $50 a day. That would be our starting number. He sells hot dogs for $3 each. That would be your growing number. Okay, but the stand would be negative, wouldn't it? Because he has to pay out, right? So your equation would be 3x minus 50, wouldn't it? And this would be f of x equals 3x minus 50. Okay, if we made a t-chart, we would have 0, 1, 2, 3. We're just going to put the first 3. This is x, this is y. We would start at negative 50, then negative 47, then negative 44, then negative 41. I'm just adding 3, right? Every hot dog he sells is going to get $3. He's going to have to sell $50 to make money. This would not be continuous, would it? It would be a series of dots. Okay, he's never going to get like $1.50 because he's selling hot dogs for $3 each. So is this discrete or continuous? It's discrete. What's the independent variable? The independent variable is the number of hot dogs. The dependent variable would be the cost, okay? Y is a function of x. Y is a function of x. Now then, let's go to number 5. Tom the painter charges an $80 flat fee. That would be our starting number. Let me do another color here. So this would be the starting number, and this would be the growing number, wouldn't it? Let's write it down. So f of x, sorry about that. F of x is going to equal to 25x plus 80, correct? So the 80 would be the starting number, the 25 would be our growing number, that would be our function rule, wouldn't it? Okay? He lists the first 5 values in the domain and the range. Okay, so we'll make a t-chart here. Let's put 0, 1, 2, 3, 4. At $0 hours, he makes $80, doesn't he? Now then, we're going to grow the 80 by 25. So all you got to do is just keep adding 25. So 80 plus 25 is 105. 105 plus 25 is 130. 130 plus 25 is 155. And 155 plus 25 is 180. This would be my domain. This would be my range, would it? Okay. Now then, let's go a little step further. Underline function of. And his charges are a function of the number of hours. His charges are y and his hours are x. So the charges, let's put hours, equals x. That's your independent variable, isn't it? The x is the charges, right? His fee, let's just put fee, would be the y, and that would be the dependent variable, right? Okay, so 0, 1, 2, 3 would be the hours. That would be the independent variable. That's your input. How much he charges or his fee would be the dependent variable. Okay, so your domain is going to be 0, 1, 2, 3, and 4. And your range would be 80, 105, 130, 155, and 180. Remember what that independent and dependent variable is. Y is a function of x. Y is a function of x. You'll have function of, underline it, find your y, find your x. The painter won't work more than 12 hours. Okay, what is his highest possible? So he won't work more than 12 hours. So 12 is not more than 12. So he's only going to work 11. So let's do 25x plus 80. And he can't go 12, so only 11 hours. 25 times 11 plus 80. 25 times 11 is, let's see, 12 times 25. 12 is 275 plus 80. So his max fee is going to be $355. That would be his max range, wouldn't it? That would be for 11 hours of work. 12 is not more than 12, so we're going to go 11 hours down. That's why we did that. Let's turn the page. These are pretty simple stuff right here. Is this a function? So all you have to do is draw vertical lines. Just slide your pencil across. This would be a function, wouldn't it? Because the pencil only crosses the graph once. This also, a vertical line, would only cross it once. This is a function. This right here, the x would repeat, wouldn't it? This is not a function. Okay, so a vertical line, if it crosses twice, the x is repeating. If the x repeats, it's not a function. Let's go to number 7. On this one right here, we're going to state the domain and the range. Okay. So number 8, remember, we're going to put 2 dots on the x-axis, 2 dots on the y-axis, and use inequalities. If there's an arrow tip, we might have infinity or just one inequality. So I'm going to zoom into number 7, and we're going to get the domain first. So we're going to go left to right on the x-axis. This graph starts here and it goes to here. So my domain will start at 0 and it will go to 40. Okay, then you put an X in the middle, then you put less than symbols, and they both have closed dots, so we need an equal bar. Oh, that's how you write down the numbers between 0 and 40. Now then, let's get the range. The range will go from the bottom to the top. So the range starts here and it goes to the top here. So these two numbers would be 0 and 16. The range is not X, it's Y. You put less than symbols in. And then we're going to see if they need equal signs. And they both do because they both have closed dots. That would be the answer. Oh, ho, ho. Fun, 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 fun. Let's do the next one because this is so much fun. Oh, 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 oh. Really not a lot of math on this test. You should do good on this test. Make sure you know the vocab words. Let's do the domain on this one. So we're going to go from the left to the right. The furthest left this graph goes is right here. So I'm going to go to that dot and go straight down to the x-axis and put a dot on my x-axis. I want two dots on my x-axis. One on the left, one on the right. The furthest right this graph goes is right here, and I'm going to go straight down to the x-axis, which would be to here. So now then I'm going to count these spaces. 1, 2, 3, 4, 5, 6. This is -6. 1, 2, 3, 4, 5, 6. This is +6. My domain is X. I put less than symbols in here. They both have closed dots, so they're going to have equal bars. Ho, 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 ho. Now then, let's find the range. The range will go from the bottom, let me change pins here, from the bottom to the top. So the furthest down the graph goes is right here. I'm going to go across to the y-axis, which will be here on it. I need two dots on the y-axis. The highest the graph goes is right here, so I'm going to dot it. These two numbers will be my range. The bottom number is 0, and the top number is 1, 2, 3, 4, 5, 6. So my range goes from 0 to 6. I put a Y, and I'm going to put less than symbols, and they both have closed dots. I'm going to put an equal bar. Ho, 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 ho. Let's go to the next one. The domain on the next one. Oh, okay. Notice that this arrow keeps going up, and this arrow keeps going right. Okay, so from left to right, my domain will start here. I'm going to bullet that, and then it will never stop going to the right. I'm going to draw an arrow tip, which will be infinity, won't it? Okay, so there's two ways to write the domain. You could put 0 to infinity, less than or equal to, and then x, right? So x goes from 0 to infinity, or you could just take out the infinity, circle this, x is going to be greater than or equal to 0 in it. So both of those could be on your STAR test. Okay, so your domain is going to be all the x's greater than or equal to 0 or 0 to infinity. Now then, let's get our range. Okay, let me turn green for the range. Notice that this line keeps going up and this line keeps going down, doesn't it? So this would go up and this would go down. There's two ways to write this. It would go from negative infinity to positive infinity, less than or equal to y's, or you could write down all real numbers. Both of those could be on your STAR test. So your range would be all real numbers. It doesn't stop, top to bottom. The domain would be 0 and more. X is greater than 0. Oh, 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 oh. We're almost done with this amazing test review. So on number 8, all we got to do is figure out if it's a function. We're going to use the vertical line test. So let me do a, what would show up best? Let's do a blue line. So this one right here, a vertical line is only crossing once, right? So I'm going to put a check. It is a function. Number 2, a vertical line only crosses once. That's a check. It is a function. Number 3, the vertical line crosses twice. That means the x repeats. So it's not a function. Number 4, this looks like it does, but it doesn't. A vertical line's only going to cross it once. So this is a function. This one right here, I could do this. The x is really repeating here 3 times in it. That is not a function. And on the last one, this is a function. Check. So 1, 2, 4, and 6 are functions. 3 and 5 are not functions because the x is repeating. Oh. And the last one, let's do number 9. Okay, on number 9, student each bar, let's do the growing, just write down gx plus s and put f of x. On this problem, do we have a starting number? If you read through it, we're selling candy bars, and each one earns $3. That $3 is going to be my growing number in it. This does not have a starting number, does it? So my function rule will be f of x equals 3x. There's no starting amount, is there? So at 0 candy bars, we got $0, don't we? Now then, okay, it doesn't tell you which is a function of which, but the candy bars would be your x and the money would be your y. So let's put x and y. Okay. Each chocolate bar, so these are the candy bars. These are the candy. This is the money, right? This would also be your independent variable. And this would be your dependent variable. The words for the x and the y are the independent and dependent variable. Don't forget that. They are not numbers. The words used to describe the x and y are the independent and the dependent variable. Those are the labels that would go on the axes. Now then, let's do the first 4. So 0, 1, 2, 3, and let's go to 4. At 0 candy bars, we would have $0, wouldn't we? And then we're going to grow this by 3. So 3, 6, 9, 12. That would be my domain and range, right? So this would be my domain. This would be my range. And lastly, would this be discrete or continuous? This would not be a solid line. We would never have $1 in this situation. We would never have $1.75. We wouldn't have $4.55, would we? We would only have money of 3, 6, 9, 12, multiples of 3. This would be a discrete function, wouldn't it? Okay, your test is tomorrow. You are going to do wonderful. Let me stop recording. And let me end this so it makes the video. You are going to do wonderful tomorrow. Remember, you are amazing. You are created to do wonderful things. Enjoy your Zen and always believe.